When it comes to climate change, in particular, anthropogenic climate change caused by an increase in fossil fuel emissions, it is an extremely well-established fact. And at the end of the day, someone who's not a climate scientist or a scientist in general, they just sort of have to trust the scientific establishment. And the scientific establishment are completely unanimous and have been for decades that it is real, it's happening. We can measure it in many different ways. The measurements are very precise, so that is not in doubt.
Hello and welcome to Care to Lead. Today I'm really excited to have with me Fran Bartolic. He is a data scientist at Salient and a leading pioneer in weather forecasting analytics. Prior to this position, Fran worked at a London-based climate tech startup, focusing on predicting the effects of climate change in dense urban environments. He has a doctorate in astrophysics from the School of Physics and Astronomy at the University of St. Andrews. And that's quite impressive, and I'm a little intimidated, but welcome. I'm glad to have you here with us today.
Thank you. I'm glad to be here.
Fran, I was really intrigued by your article in Authority magazine. In the article, you talked a little bit about how your career path wasn't necessarily traditional. You kind of had two thoughts in mind when you started out. You want to share more about that?
Yeah, so essentially, throughout my academic career, I studied physics, focused specifically on astrophysics, even more specifically on studying exoplanets, which are planets orbiting a star other than the sun. And I kind of sort of stumbled into that. I didn't really know exactly what I wanted to do at the end of high school. And then essentially what happened is towards the sort of later years of my bachelor's program, I got an opportunity to do some research in astrophysics, and then sort of continued on that path and I enrolled into a PhD program. And at that point where I enrolled into a PhD program in astrophysics, most of those PhD programs are very much focused on the academic track, even though the vast majority of PhD students, when they graduate, they end up outside of academia. The assumption is really that you're going to stay in academia, and so the whole program is tailored very much towards academia. So I knew that the stats weren't really working in my favor, and I knew that I want to be flexible when it comes to career choice. And essentially at that point, I was quite interested in the intersection between sort of data science and machine learning and statistics and sort of research problems in physics and astrophysics. And I wanted to pick a program that I knew would enable me to sort of switch careers after I graduate if I decide to not stay in academia. And I found this program that was quite experimental at the time in the UK. And essentially, the novel component of that program that we had a lot of courses on topics such as machine learning and statistics. And then also we had this 6-month placement period in a private company, working for a tech startup. And the idea was that sort of, if we had decided to move out of academia, we would be a lot better prepared afterwards. And even if you stayed within academia, there's a lot of skills that are transferable from business into academia as well. So that turned out to be a great choice because in the end, I decided that I definitely don't want to stay in academia. And I managed to find this job that I'm working at right now at Salient Predictions, which happens to be, the work happens to be quite similar to what I was doing within astrophysics. So equally enjoyable, equally fun, and a lot less restrictive in terms of, I can move freely. I don't have to chase postdocs and such and 2-year contracts. So I'm quite happy with that.
So what's the most interesting thing about your day-to-day job right now?
I think the most interesting thing is that every day is different. For instance, today I'm doing this interview, which is quite out of the ordinary for me. But then every day we're really sort of solving new, very specific technical problems. But often kind of what we're doing is it's not a very common problem. It's not a very standard problem. We are trying to fundamentally do something quite novel. And, that involves solving lots of different smaller, like novel problems day to day and like so fun little puzzles. And then, every day you have to think about how it fits within the bigger picture and where you want to go in like, a few months' time, a few years' time. So I think that's my favorite part.
So your bigger overall role in what your organization is trying to do is get more accurate predictions of weather. Is that correct? With everything happening, I just returned from Hawaii last week, and I was there just before the earthquake, and I was glad to be there just before the earthquake. But it seems, from my perspective, that I'm not an astrophysicist, obviously. So my perspective is very naive, but many of our listeners may be not astrophysicists also. So I'm going to ask you, all the things that I'm seeing, it seems to be that I'm seeing more of right now, these rogue waves that are coming out of nowhere, and the earthquake in Hawaii, and then the earthquake in San Francisco and in California, and then just the extreme weather everywhere. What are your thoughts on what's happening and what's going to happen in the next few years?
First of all, I'm by no means an expert in weather forecasting and climate science, so take everything I say with a grain of salt. I think when it comes to earthquakes, for instance, those aren't connected to climate change in any way. I think if you look at some historical data on earthquakes and the responses to earthquakes, I think we're actually, in terms of casualty numbers for a given earthquake or for a given magnitude, we're doing a lot better than half a century ago or a century ago. So those are always going to happen, and the only thing that we can really change is how we respond to them. I think there is work on trying to predict earthquakes, but it is extremely difficult, if not impossible. When it comes to extreme weather, that's quite a separate topic. And again, there has been extreme weather, continuously throughout history. And again, also, I think that when it comes to extreme weather, our response to extreme weather events has improved. But certainly my understanding of climate science and like how climate change affects extreme weather is that I think we can quite confidently say that for certain kinds of extreme weather events, those are going to become more frequent. But it is very difficult to disentangle the effects of climate change on extreme weather versus extreme weather that would have happened even in absence of climate change. So I think that one has to be quite careful when attributing any given hurricane or a flood to climate change. But at the same time, the overall pattern that these events are becoming more frequent, I think scientific consensus is that is almost certainly true.
That's an interesting way that you put that, because I was having a conversation on another trip that I was on, and I was talking with a gentleman, and it was during just extreme heat. And so he was from Texas, and where I met him was in Maine, because there were a lot of people in Maine at that time of year trying to get away from the extreme heat. And we had this conversation, and I made a comment about, well, that's global warming or something. And he said, similar to what you said, it's like, well, the extreme heat has been here forever. There's no, it may not have anything to do with climate change. And that made me start thinking, I gathered from his conversation later that he doesn't even believe climate change is real. So there has been extreme weather forever, and there probably will be extreme weather forever. So what do you say to someone who says, because of that, climate change, that's their evidence that climate change is not even real, or that there's not a problem?
Yeah, to be clear, the effect of climate change on different kinds of extreme weather events is it's not uniform. So when it comes to extreme heat, for instance, I think that's one of the most predictable consequences of climate change, and it's, I think, relatively easier to attribute, say, for sure, an increase in sort of a yearly mean temperature or summer sort of peak temperatures to climate change than it is, for instance, to attribute an increase in the number of sort of hurricanes to climate change. I'm pretty sort of sure that's true, but again, don't call me that because I'm not a climate scientist. As to what I would say to that person, it is quite difficult because all these sort of questions are quite subtle scientific questions, and people usually want sort of simple answers to these complicated questions. When it comes to climate change, and in particular anthropogenic climate change, climate change caused by an increase in fossil fuel emissions, it is an extremely well-established fact. And at the end of the day, someone who's not a climate scientist or a scientist in general, they just sort of have to trust the scientific establishment. And the scientific establishment are completely unanimous and have been for decades that it is real, it's happening. We can measure it in many different ways. The measurements are very precise, so that is not in doubt. But again, when it comes to a particular event, I don't think you can really, it's very difficult to answer the question, would this heat wave have happened were it not for human-caused climate change, or if the climate change was less sort of intense? Because answering that question requires sort of a very good model of climate and also a very good model of sort of human influence on the climate. And that's an active area of research, and it's not a trivial question to answer.
Let's talk about weather prediction and the accuracy of what is predicted. In my lifetime, I've seen it become seemingly more and more accurate. Like they can predict a tornado on a certain block, at a certain time. Granted, there's always going to be probably outliers to that. But tell me a little bit about what's changed to get that accuracy and continue to get that accuracy, and how is AI playing a part in that?
Yes, essentially there has been, I think, the first sort of large-scale physical weather models have been developed, I think starting in the 50s or maybe even the 40s. And so these are models that are developed by very large sort of scientific institutions. The development of those models involves hundreds, if not thousands, of scientists. The models use a lot of computing power. They use supercomputers for training. And we've seen pretty much sort of continuous improvement in the accuracy of those models. So you're certainly, your sort of observations from day-to-day life are certainly true. There has been it's pretty much sort of steady improvement in accuracy. And essentially now in the past 2 years, we're starting to see sort of, in a way, totally different approaches being developed from mostly from major sort of tech companies using AI. And those models are now starting to beat the previous state of the art. And so I sort of think that you might see a little bit of a step change now in accuracy. But one thing that we should always keep in mind is that you can always, the prediction, so the forecast accuracy declines with the lead time. So the further in time you want to predict the weather, it gets much, much harder. And that's something that's always going to stay true. It's just that we're going to, we have been gradually pushing that horizon a bit further. And I think I'm very excited to see how far we can push the horizon using AI.
What is your hope for, where do you see it going, or what are you kind of excited about?
Well, I'm excited about these machine learning models that can be trained by essentially a very small group of people using a very small fraction of the resources that were previously required to train weather models. I'm excited for that to be sort of something that, even some individual small research teams can do, even so people outside of science can do, if they essentially, at this point, if you have enough GPUs and you know what you're doing, you can sort of create your own weather model that's almost as good as the state of the art. Super impressive. And then I'm looking forward to sort of seeing. I'm looking forward to see where it all goes.
I like that. So another thing you said in your article that piqued my interest, I thought was rather interesting, is we were talking about skills and what skills will still be relevant in the future. And one of the lines you said is it's hard to imagine that skills like prompt engineering will be relevant a few years out. And I thought that was interesting because I have been doing this series for a while on how AI is interrupting different industries. And one of the things that people continually say is that prompt engineering, so to speak, is here to stay, and it's going to be this entire field by itself. But you had a different take on that, and I kind of like that. Would you like to speak more on that?
Yeah, so essentially, in the past, again, sort of 2 years, we've seen the development of these large language models and chat interfaces to these models. Essentially, is the realization of the many decade dream that AI researchers have had to someone to be able to just talk to the computer and for to sort of show elementary signs of even reasoning ability and just sort of tell you the answer that you want to hear. And what people have very quickly found is that so just users of these platforms like ChatGPT, they've discovered that these models are quite sort of unusual beasts. They're not at all similar to sort of depictions of AI from sci-fi movies. So if you think of films like 2001: Space Odyssey and the HAL computer, they usually sound very robotic. They're quite logical. Or for example, if you look at Star Trek, you look at Data. So those are kind of like our preconceptions of what an AI would behave like. But then as soon as people started talking to these to ChatGPT, they realize that they're quite different. In fact, they're very sort of unpredictable, and you have to oftentimes you have to persuade them to give you the answer that you want. You have to sort of provide lots of additional detail. You have to sometimes even apparently trick that works. If you promise to tip ChatGPT, it's going to do better. If you say like, I'll give you $20 if you.
Really?
Yeah.
I haven't tried that.
Yeah, so they're quite unusual. And essentially, this skill, which is like, persuading the model to do what you want, that's called prompt engineering. So the prompt is simply the text that you enter into the chat box that is then processed by the large language model. And essentially, I mean, that skill can get quite, it's essentially just writing. And I guess the only argument that you can make that, and everyone expects that as the models improve, they're going to need less prompt engineering. So you're not going to have to put that much effort into explaining what you want. You're just going to sort of expect that the model is intelligent enough to figure out what you want. So I just find it hard to believe that 10 years in the future, even 5 years in the future, there will be these like so specialized jobs where people are like extremely talented to talking with the models. I mean, essentially, like at the end of the day, the skill that we're talking about is just writing and speaking. So if you rebrand writing and speaking as prompt engineering, then yeah, sure, it's gonna say it is.
That's very valid. And you're actually right, because it does learn so much. And especially for someone like me who has absolutely no coding, no way of writing an official technical prompt for ChatGPT. I just go in and I'm like, "Good morning, Chat." And I wrote this, and could you make this more concise? And like recently I put something in there and I said, I want to say this in more succinctly. And its response to me was, well, you don't like bullet lists, so I don't know how to make it more succinct. It was like being sarcastic. I'm like, wow, I'm getting, snark by ChatGPT.
And we already have a large zoo of these models. So GPT-4, which is made by OpenAI, is by far the most advanced ones. But you can also play with much smaller models. And what you see is that already the smaller models they need a lot more prompt engineering. They need a lot. You need to put a lot more effort into explaining what exactly it is that you want. And GPT-4, often when I talk to GPT-4, I'm just often very lazy and just sort of type, even a grammatically incorrect sentence, and I just sort of expect it to know what I'm getting at.
That's what I do.
And the majority of people now, it kind of does. It kind of does know exactly what I mean.
And sometimes it knows better than you know what you mean. It's like, that's not what you meant. You wanted to say this. That's kind of fun. Tell me more about your company and what your plans are with the company and how large is the company and how are they growing?
So essentially we are still a seed stage tech startup. I think we've been around officially for 5 years, but we're still, I think, very much in the early phase. Most of the phase is still trying to find product market fit. Our goal is relatively simple. It's to improve sub-seasonal forecasts. So these are forecasts from roughly 10 days out to a year into the future, and using machine learning. And then also not only to release those forecasts to customers, but also to build products on top of these forecasts that sort of enable the customers to get useful insights from the forecast, because forecasting the weather is a very challenging problem, but then also knowing how to use the information about what the forecast is another challenging problem. And different customers have sort of different, very, very different use cases for those forecasts.
So who are your ideal customers? Who do you market to?
So yeah, we've definitely been trying to figure that out over the past year, and I would say that right now we are mainly targeting, first of all, usually large corporations, such as sort of agriculture companies, and then also right now we're very much focused on commodity traders. The reason why we're focused on those two customer profiles is because when you look at the forecasts, at this S to S time scale, you can't really say anything with certainty. So the forecast for the weather up to, a few days, they're now, quite good that you can even, with very high confidence say that the temperature on day 3 into the future is going to be like within a very narrow range centered around a specific value. But as soon as you look at the weather, like, sort of seasonal timescales or weekly timescales, it becomes a much harder problem, and you can't really say anything with certainty. You have to sort of report probability distributions, which basically which give you, like a measure of uncertainty around a given value of any given physical variable that you're interested in, like temperature or precipitation, wind speed, or so on. So the customers who are most likely to effectively use that kind of information, this probabilistic information, are large corporations and commodity traders and such, because the predictive edge that we have over our competition is relatively small. So if you want to make use of that predictive edge, you have to make lots of different decisions over an extended period of time, and ideally also over the entire globe, if possible. And that is only really worthwhile for companies that are in a position to make repeated decisions.
Okay. So I'm going to ask you a question, and if you don't want to answer it, you can say no. But I'm curious if you have a case study that you could share, or an example of an organization or something that has really used your predictive analysis to make a difference for them. Like, what was the result? Do you have any case studies, success stories?
I cannot think of anything off the top of my head, but we have a blog on the company website where we're thinking about producing a lot more content along those lines, thinking not just about the quality of the forecast, but also how to make use of the forecast in order to, at the end of the day, have a higher ROI or cost savings or whatever.
Mm-hmm. Yeah, because I'm sure that our listeners are probably very interested in, because we have a lot of executive level leaders and big organizations who follow Authority Magazine and who listen to these interviews. So I'm sure that as your blog grows, you'll be able to get a lot of following on people who want to learn more and more. Are there any myths about your industry that you'd like to have an opportunity to debunk right here and now?
Yes, it is it's pretty much impossible to give a very precise forecast of the weather on a particular day more than, say, 2 weeks in the future. So we will never have a model that tells you, say, if it's January 1st today, you will never have a model that tells you what the weather is going to be like with high certainty on, say, March the 14th. However, you can say something about, say, is the summer, if you're talking about if today is January 1st, and you're asking the question, is this summer going to be sort of warmer or cooler than average? You may be able to get that question. So the further into the future you look, so you have to look at longer time horizons and also greater regions. So you can't exactly forecast the weather, say, for New York City, but you may be able to say something about the weather for the entire continental USA. Understanding what the limits of these models are is absolutely crucial for effectively using the forecasts.
How do you think AI is going to expand those limits? Do you think it'll expand it a lot, or just make it just more accurate in the closer, it's still going to be like a time, it can only go so far out, but it'll be more accurate in that time, as opposed to AI will change it so it can go much further out?
I think it will push that horizon. Both of those things, both of those options that you mentioned, I think both of those things are happening. But there will never be like a huge jump in our capability to predict the weather, because that just goes against fundamental physics and sort of chaos. So this problem of, how to effectively use a probabilistic forecast, which is potentially, only say 5% or 10% or 15% better than the alternative forecast, that's going to stay relevant forever. Investing a lot of resources into thinking about how to communicate that fact, and also how to build sort of tools and products that really make use of that predictive edge that we have over the competition.
So what would a young person who is considering following kind of your career path, what advice would you have for them?
That's a good question. I think definitely learn basic STEM subjects, learn physics, math, biology, and then also become very good at writing code, understanding other people's code, and then just sort of, I would advise them to follow their passions, because there are so many resources right now on the internet that it's really easy to learn pretty much whatever one is interested in. So if you're excited about machine learning, there are, hundreds of courses. There are top researchers in the world. You can just talk to them on Twitter if you want and ask them questions. And sometimes, the courses that they give at their universities are also publicly available. You can submit code on GitHub. You can join some existing organizations, projects. I don't think that you need a PhD to do that. But it's a great time to get into machine learning or any STEM related subjects really.
It actually, when you talk about those things, I can actually hear excitement by you. You really are passionate about your work, aren't you?
Yeah, it's great fun. I'm very happy that I can do this and also get paid for it.
So in your Authority Magazine article, there's a group picture. Is this your entire team that you work with in the magazine?
It was the entire team at the time. I think we've added 2 extra people since then, or 3. I think it's about 17 of us right now.
And where are you physically located, the organization?
Well, we're officially based in Boston, but we're all scattered around USA and also the world now with Croatia. So really all over the place.
Where was the picture taken that's in the magazine?
The picture was at Cape Cod, Woods Hole.
So you guys are all doing an important work in Cape Cod. When I go, I'm just like hanging out. It's good that we have people doing important things.
Working remotely is, there are challenges, and make sure to have these in-person offsite meetings every, I think, at least sort of 6 months or so, if not at a higher cadence. So usually we pick a nice location and spend a few days together and discuss the problem.
Now you're speaking my language. So tell me more about what happens in those. And when you bring your teams together, what kind of activities do you do, and how do you? One of the things as an executive leadership coach, I always tell people is it's build connection before content. Start building that teamwork. And when you're a remote team, some of those interactions are even harder to get on a daily basis. So tell me what your teams do when you have offsites like this.
So I think that we are still sort of trying to find the perfect format, but essentially at a high level, we have a few days together, maybe 3 to 5 days, and we spend half of the time doing work-related activities, either company all hands meetings or focused team-specific meetings and co-working sessions. And then the other half of the time, we have fun activities that are tied to the particular area where we have the offsite. They're meant more as a team building exercise. I think the format works quite well. Honestly, I think that by far the most important thing is just to meet physically, because then just working remotely becomes a lot easier, associating a person to a face that you see on Zoom or Teams or whatever. And then everything else is a bit, finding the optimal format. I think we're still looking for that. Although I think that the past few offsites that we had have been quite successful in retrospective.
That's fun. What do you find the biggest struggle for? And I'm not talking about the science and technology behind what you do, but just the day-to-day business. What are some of the bigger struggles you have being a completely remote team?
I mean, for me personally, within the technical team, sometimes I forget that I'm working with other people on a shared goal, because usually, I have my own technical puzzle for the day, and occasionally I have to talk to someone else, but oftentimes I can just end up working on it for days at a time. And we don't really have that many meetings, which is, usually a plus, but then there are also drawbacks because you don't see other people. But those are the challenges that I face. I think building alignment within the team and building also alignment within the whole organization while being fully remote is quite tricky. And I think it probably requires a lot of, it requires some, repeated connection, either through one-on-ones or meetings with several people.
And I'm going to guess that most of the people you work with are also scientists, and many of them probably more introverted than extroverted. That probably makes it even more challenging, right? Because they're all happy to work on their own puzzles all day long.
That's definitely true. Although one consequence, if they're introverted, then they may be more comfortable with speaking to someone online and more open than they would be in person. So there are pluses and minuses there.
Where can our listeners get a hold of you? And I guess on a couple of different levels. So if there are investors who are saying, what he's doing is really interesting, I'd like to learn more about investing, or a potential customer saying, what they're doing is really interesting, how could I learn more? Where is the best place would they reach out to you, or just the website?
Probably not to me, because I'm just a member of the technical team. I think that the best bet is going to salientpredictions.com. I think that is our URL. or also reaching out to us on LinkedIn, the CEO directly, Match 9. And if you're curious about sort of any technical aspects of the project that I'm able to share, feel free to contact me through LinkedIn or Twitter or email or whatever.
I'd be interested to see if maybe we can get an Authority magazine article by your CEO too. I think that our readers would love to hear from him. So it's going to go in the back of my mind. Maybe we'll reach out.
He's been doing, I think, podcast interviews and such few times.
Well, I genuinely appreciated speaking with you, and I can't thank you enough for being here today. You shed a lot of light on things, and I think I will be kinder to my husband whenever he picks one city for vacation over another and we have bad weather and I'm going, but you said it was always in the 70s at this time of the year. We went to, we went to Scottsdale and Phoenix and Sedona last year, and it was like February, and it's supposed to be like a little cooler, but not. It was so cold. They had this freezing snap, and I was cranky to my husband the entire time, as though it was his fault that it was cold in Sedona and cold in Phoenix and cold in Scottsdale the entire trip when we could have gone to Florida where it was warm. So I will be kinder knowing that there's no way to really predict, although I think I knew that anyway.
I'm happy with that.
Anyway, thank you so much for your conversation today. And we will be following you and your work, and our listeners will too. So thank you very much for being here.
Thank you very much. This was great fun.